and welcome to Amazon Web Services webcast, securely delivering high-quality content with AWS and Wowza. My name is Usman Shakil, and I'm a principal solutions architect here with Amazon Web Services. Along with me is Ryan Jesperson. He's the training and support manager with Wowza. Today we're going to talk about securely delivering high-quality content on AWS. So it's fascinating to see the type of different use cases that Amazon Web Services enables for its customers. Even take today's topic, securely delivering high quality content. What is content delivery, right? It could be a use case where my mom wants to upload our family pictures, videos, and share with her family, myself, my wife. It could be any one of you uploading their videos and wanting to stream even live content to companies like Netflix, Amazon Instant Video, who want to use the scalability, security, and agility of AWS to deliver high quality content. So let's dig right into it. Different use cases around content delivery call for different security measures. So as I mentioned, the use cases really determine what type of security you're going to be looking for. So if it is a user-generated content that can be free, open, and you want to reach as many audience as possible, you can have it completely open and public. Or it could be free or secure content, so stuff that you want to give access to a specific set of users. You can do signed URLs for that. It could be content that is ad supported. In that case, the content owner wants to make sure that there is some encryption so that even if the content gets lost or accessed by unauthorized people, it's at least encrypted. And then there is premium content that could be live broadcasts or video on demand. So things like Netflix, Amazon Instant Video, for example, they would put a lot of security measures on top of the content for delivery. And then finally, I would say the highest classified type of content, like pre-release content that the studios have, where they have content which is, say, pre-theatrical releases, etc., for the full-length features that they want to share with their different vendors or affiliates for different services around that content. That is classified as the highest level. So there are different levels of security that one would want to implement on top of this content based on the underlying use case. So what are different mechanisms that are available to a content owner when talking about secure delivery of a media stream? So we talked about tokens, signed URLs. That would be a signed URL or based on a specific, say, start time and date, and end time and date, and even specific to a set of IP ranges or users. So that is the kind of methodology that, say, if my mom is using some application to share the content, the family pictures, etc., to her family members, that application specifically would be using something like that, for example. Then there is AES encryption that allows you to encrypt your content, and you could send encrypted video over HTTP to protect the content from non-authorized streaming. So let's say if the content is acquired by somebody who's non-authorized or not licensed or does not have the rights, have not purchased that content, even if they get access to the content somehow, it is encrypted and they will have to get an encryption key or to decrypt that content in order to make any sense out of it. So in that case, we see this kind of methodology pretty predominant in the case of ad supported videos, or in the case where, say, there is a monthly subscription type, etc. Then there is DRM. It's very similar to AES encryption, but it also adds a business rules layer on top of your encryption. So for example, you can give time-based access to somebody where they can view the content only for a day or a couple of days or for several say times, occasions, etc. Then different types of content you want, as a content owner, you want to make sure that it's not accessible throughout the world. I mean, there could be use cases, right, where say for a piece of content you do not have the license rights to share that content across the globe. So that's where geo-blocking comes into picture, right? So you will often see services like Netflix or Amazon Instant Video. While you can watch a piece of content within the US, it may not be available to you when you're traveling outside. So how do they implement it? That's really how you implement using geo-blocking. And then finally, watermarking. This is highly used in the cases where it's, say, pre-release content in the case of the studios, when they are sharing different proxies for the content or the content itself to different vendors or affiliates, etc., for different parts of their media processing workflow. So in this case, again, even if the content is somehow leaked, they want to backtrack it. They watermark it either through digital watermarking, forensic watermarking, so that they can backtrack the source of that leak. So these are some of the predominant sort of say mechanisms of how a content owner can really go and secure their content. So what are some of the feature set that AWS services provide you right out of the box, or as native feature set, that help you build a highly secure mechanism to deliver your content? So we talked about, first of all, signed URLs or tokens. So Amazon CloudFront, that is our CDN service, has a feature for private content streaming or private content. And natively, it supports signed URLs, signed cookies, OAIs, etc. Then there is AES encryption, Amazon Elastic Transcoder, again, our scalable, completely managed transcoding service, gives you the capability to do HLS, HLS with AES 128 encryption. You can also use encrypted media files from the storage as well as processing, and the processed segments individually can be encrypted. And we'll talk about it, and I will actually demo it later, part of the presentation today. Amazon Elastic Transcoder also integrates very nicely with some DRM solutions, specifically Play-Ready DRM packaging. So from your perspective as a user, if you're using Elastic Transcoder, you simply check a box and provide your configuration settings for your Play-Ready server, and it automatically integrates with that. And again, we will visit that in a demo today. Amazon CloudFront has the capability for geo-blocking. So you can go in and restrict certain geographies where you do not want your content to be viewable or accessible from. And again, this is a native feature within Amazon CloudFront. For watermarking, Amazon Elastic Transcoder allows you the capability to implement visual watermarks on top of your content. So as you can see, just by the virtue of using these services within Amazon Web Services suite of these different services, you can build a solution just by simply selecting these native features that are available within these product or services set. So let's visit here a sample architecture of, let's say, if I was to go and do streaming, right, for say on-demand content, file-based or live streaming, how would that look like? So the first piece here, as you can see on your screen, shows you from right to left a flow where, as a content owner, you upload a media file into an S3 bucket. S3 is our simple storage service where you will be actually storing your content files. And then from there, you can simply trigger an Elastic Transcoder job. Again, as I mentioned, Elastic Transcoder being our managed transcoding service. You specify the type of transcoding that you're looking for from a presets configuration perspective. And Elastic Transcoder will transcode that file for you in different renditions and different formats that you define, and then put it back into S3 bucket. You can use that S3 bucket where your output files are, or say pre-segmented content, etc., lives, and front it with a CloudFront distribution. So basically deliver it directly through the CDN. So as you can see in this workflow, there is really no servers involved. That's pretty cool in a sense, that you could start by just simply uploading an S3 bucket, and with the help of services like or features like S3 notification and also Amazon AWS Lambda, you can really automate this entire workflow without any single server. That's pretty. I find it pretty fascinating. And then some of these security features, as we will revisit pretty soon here, are native to these services. So you get encryption basically for free if you look at it. You can also impose things like from S3 to CloudFront. So basically, the interaction between these different services, you can impose HTTPS or SSL-based access only, both for S3 and CloudFront. Now let's revisit the live streaming workflow. So in the case of live streaming workflow, you will have an RTMP stream that is being generated from your, say, source device or on-device encoder, for example, which will be ingested by a media server, for example, Wowza, running on an Amazon EC2 or Elastic Compute Cloud instance. So a media server like Wowza can encode or transcode real time, and basically, again, depending on the type of format that you want to deliver, it can simply deliver over HTTPS to CloudFront, and that could be in multiple different formats from HLS, HTS, Smooth to MPEG-Dash, for example. Again, the services, the features from a security perspective, and we'll talk about it, that are native to EC2 can be leveraged directly with Wowza because Wowza is running on EC2. So let's visit some of the security features that that will be interesting to you in the context of your content security or content secure content delivery. So first of all, as we talked about in our architectural diagram, you will upload your files into an S3 bucket, which is our storage service. So Amazon S3 provides you bucket and object level permissions. So what that means is that anytime you upload a file into S3, by default, it is only accessible by you. So earlier in my example where my mom uploads the files using an application into S3, those files are only accessible to her unless she gives explicit permissions to me, my family, or other members of the family to go access it. And same applies for somebody like a Netflix who is using that as a location to put their source files that they get from the studios. So by default, only the owner of the bucket has access to those files. How do you give permission? You have to explicitly give permission by either generating a signed URL or query string authentication, or through identity and access management policies, where you specify specifically that a person or a group of people having a specific permission or belonging to a specific IP range can have access to this file for a specific period of time that you can mention through the signed URL. Now, that's good. You can give permissions to your users, but you also want to make sure that even if you give permissions, there are additional checks in place so that somebody doesn't just go in and accidentally delete your content. So first of all, the permission is specific to specific S3 functions. So you can give permission where it is read only, or it is read and update, or read, update, and delete, or the entire thing. But even on top of that, as an added layer of security, you can put versioning or enable versioning in an S3 bucket. It's just simply a mechanism where you just simply go in and check in a box and enable versioning. So what that means is that even if somebody goes in and deletes an object accidentally or a file accidentally within S3, the other versions of the file will be saved. Or you can enable MFA delete, which means that somebody will require a multi-factor authentication to go in and delete that object. And anytime any one of your users is performing any function or accessing anything from your S3 bucket, it is being logged. And we have customers, large enterprises, large studios that are actually using S3 today for their content storage. And they highly leverage this access logging to actually do real-time analytics on it and trigger notifications if anything was to happen. So it's a great mechanism to actually look at what's happening on your S3 buckets. S3 also provides you encryption natively, both server side at rest and client side. So in fact, you can encrypt your object before you send it over to S3, and you can enable S3 to encrypt it again when the object is stored at rest. And you can use SSL or HTTPS only transit mechanism to S3, so it's encrypted in transit as well. In terms of the encryption keys, S3 gives you the capability to either use its own encryption keys, or you can bring your own. So you will actually give your key to encrypt a particular object. S3 will use that key to encrypt the object, and then it destroys that key. And anytime you request the object back, you have to provide the encryption key for it to decrypt the object before it's returned to you. So highly, if you look at it, many different controls that, again, going back to the level of use case, the level of security that you're trying to implement, you can for your object or your file content security. Let's quickly talk about CloudFront because in this particular architecture, as we talked about, we will be using CloudFront for delivery of the content. So first of all, CloudFront gives you custom SSL certificates. That means that you can bring your own SSL cert, so if you want to have a branded one. It also provides you a private content feature. That means that it will only deliver to securely signed requests. You can enable HTTPS only. That means that if somebody requests through HTTP, it won't provide that content. And then HTTP to HTTPS redirects are there. It will require from your S3 perspective, let's say, since your files are being stored in S3, you want to make sure that only CloudFront edge locations have access to your content. And if some end user tries to go straight there, it will be denied. Right, so you can enable all that within the configurations of S3 and CloudFront. There is signed URL or signed cookie variation that you can enable. And then even if you're using a custom origin behind CloudFront, so for example, in the case we're gonna also talk about Wowza as being a custom origin, that can be used as well, and you can enable HTTPS only access in the case of from origin to CDN. And then finally, just like S3, you can also enable access logs on CloudFront. It also gives you reporting. And CloudFront just launched a secure cookie feature recently. So what that enables you to do is to actually bypass the whole signed URL stuff. So in the case of especially live streaming, what we're going to see is that it could be pretty hard to generate a signed URL for each and every individual segment or the manifest file. So you can simply use the CloudFront secure cookie feature where CloudFront will verify the presence of a cookie, a signed cookie within the user browser before actually responding to the request. Now, Amazon Elastic Transcoder, as I mentioned, is our managed transcoding service. Again, has a lot of security features built in. First one, starting at encryption at rest. So basically, from your perspective, you're putting your files in S3 that are encrypted by you. You can manage the keys yourself. The inputs are requested from S3. It will do the transcoding and will send the outputs into S3 as well. And you can enable encryption by providing your own keys or using Amazon Key Management Service, which we'll talk about in a second, to provide that capability or managing the keys for you. The encryption of HLS streams, smooth streams, DRM integration comes out of the box through Elastic Transcoder. These are some of the really key new features that we recently launched within Elastic Transcoder. So again, it gives you a pretty robust type of a platform where you don't have to go and manage things like encryption or things like media processing, etc. It simply starts with a process where you upload the files and the whole workflow can be automated, including encryption and content security. So Amazon Key Management Service is a new service that we launched last November. Basically, what this allows you to do is it allows you to create, describe, and list keys. In other words, even manage your master keys at a very, very cost-effective manner. So basically, you can upload or create a master key within Key Management Service, and then you can use that key, master key that you have created and managed within Amazon Key Management Service to encrypt and decrypt or re-encrypt data as well as your content keys. You can also use KMS to generate data keys that your applications can use to encrypt or decrypt data for you. An example is Elastic Transcoder. So from your perspective, as you will see in a demo in a few minutes, is that you will create a master key within Elastic Transcoder and master key within Key Management Service, sorry, and Elastic Transcoder will have a role to call the Key Management Service on your behalf to get an encryption key to actually implement encryption, HLS, AES 128 encryption on your behalf for you. So what that means is that you're using your own keys to actually encrypt these segments that you're delivering. That's a very powerful feature. An important thing to consider also is IAM roles. So as we talked about, it's great that there is a key management service, there is integration between these services and key management service in order to do this handshake or share these keys, etc. But one important consideration here is that you can do all that programmatically via identity and access management roles. So in other words, there is never a key sharing within a human or a manual mechanism. So services, so basically whenever, say, for example, you're launching an EC2 instance with a Wowza server running on it, you can launch that EC2 instance with a role that has the permission to go read from an S3 bucket or the permission to call a key management service to get encryption, encrypted or decrypted on your behalf. And same goes for Elastic Transcoder as well. So let's move on to the demo. Enough of the PowerPoint stuff, I guess. So first demo is going to be our on-demand streaming. The components that we used are S3, Amazon S3 for storage, Amazon Elastic Transcoder for transformation and encryption, and Amazon CloudFront for global delivery, as well as Amazon AWS Key Management Service for managing the encryption keys for us. We'll use JW Player for the delivery. And really what we would like to show here is the high availability, scalability, and the low cost that is offered by AWS. And as I talked about in the architectural slide, that the entire workflow is completely automated without any servers that are being used, and end-to-end delivery of the content. So right here again is a quick recap of what happens. So as a media owner, you're uploading a file in the S3 bucket, that is your content file. And then as a media owner, you're sending your master key to Key Management Service, which is managing it or saving it for you. You can actually use KMS to generate a key for you. So in this case, as a media owner, you are sending a key which you're going to use to encrypt the content. Key Management Service will actually encrypt that encryption key and send it back to you. Then you call the Elastic Transcoder and you send that encrypted key to Elastic Transcoder. Now keep in mind, throughout the transit, this key, encryption key, is encrypted. The Elastic Transcoder has a role to, first of all, call or get the file from an S3 bucket, and then secondly, also call Key Management Service on your behalf. So Elastic Transcoder gets a key from Key Management Service and the file from the S3 bucket. It will transcode that and encrypt it into HLS segments, and now this encrypted content, which is the output, lives in S3 bucket. From there, we use JW Player and the S3 bucket fronted by CloudFront to actually deliver the encrypted segments to the player, to the user. And then the user can actually call an application that, in this case, we're using DynamoDB to store key values as key value store for different files and keys. So the users will come in, they request a key, the key in DynamoDB is encrypted. The EC2 instances will use that key, send it to the key management service to decrypt that key, and then that key, decrypted key, is shared with the player, which then uses to decrypt the content and play it for the viewers. So as you can see, a complete end-to-end from ingest all the way up to delivery workflow that could be integrated with different AWS features to deliver a secure stream. So let's move on to the live demo here. I'm going to go ahead and switch screens. So on the screen now, you can see my AWS console. And right now, I'm logged into my S3 console. And it's under the folder called VOD. And right here is my source file, the Muppets show that I'm going to be using as an example. And as you can see, it gives me different properties of my file. I can enable server-side encryption if I wanted to. As I mentioned, this is a feature which I can simply enable right here. So that will enable content encryption at rest as well. Permissions, I can specify permissions for the content. In this case, as you can see, only I have access to this file and nobody else does. And so, if I tried to go straight in here and try to access the file, basically it will give me a permission denied. So that's in the S3 console. The file has been uploaded already. Now I'm going to go to Elastic Transcoder console right here. And as you can see, there is a concept of pipelines, there is jobs, and there is presets. So pipelines is a mechanism. Think of it as more like a queue. So as a user, when you sign up with AWS, you will have access to Elastic Transcoder. You will have access to you can create 4 simultaneous pipelines. So that means queues. So if you want to say prioritize your jobs, you can do that. And the benefit here is that it's a fully managed and highly scalable service. So you don't have to worry about, say, spinning up a farm of transcoders be ready for you when, say, a lot of files hit all of a sudden. We will scale the underlying processing for you, or transcoding for you, once we see the amount of content or amount of jobs, the number of jobs that are there. And you can configure that pipeline right here, with things like what is the key, etc. All that sort of information. Presets is a way to configure sort of say your outputs or your pipelines, right? So as you can see right here, there's a lot of system defined presets. So we have done a lot of work here to make things like like for Kindle, Fire HDX, NTSC, MPEG, Full HD, etc. So all these presets are predefined for you, and you can create your new preset for a different device or different rendition type, etc. For your job as well. So I'm going to go ahead and create a new job right here, going into the Jobs tab. So what this is going to do is this is actually going to create an Elastic Transcoder job. So I'm just going to click on VOD demo is my pipeline that I'm going to use. And then I'm going to select my Muppets file that I had uploaded there. And I'm going to specify a folder in S3 where this is going to go and live. I'm going to select a preset. In this case, I'm just going to simply go to HLS 600K. As you can see, there are many different presets that you can select from. I'm going to select a 10-second duration, and my output key, I'm going to define a output key name right here. I don't want to create any thumbnails, no rotation, encryption parameters. I'll talk about it in a second here. I don't want to do any watermarking, but as you can see, all these things, it's just a matter of selecting a configuration, and it will add those things. And everything here that you see is also available through the API or SDK that you can programmatically create as well. So in the case of playlist, I'm gonna give it a name right here. I'm gonna select HLS v3. As you can see here, I can select from HLS v3, v4, smooth, etc. For my playlist. And I am going to select this right here. So this is very important, content protection, right? So in this case, I'm going to select HLS AES encryption. By the way, as you can notice here, I can also select Play Ready DRM and actually point my license acquisition URL, and it will integrate nicely with that as well. So I've selected HLS AES encryption, and I'm going to say I want my keys that Elastic Transcoder is going to generate for me to be stored along with the segments of my file. So I'm just going to simply go and create a new job. So in this case, I have actually pre-generated the files or the outputs inside this Muppets folder. So as you can see, Elastic Transcoder has generated the key, the manifest file, and the TS segments for my HLS delivery. I have also generated a CloudFront distribution for my delivery here already. And so here is my application that I'm using as a front end to actually go and deliver the content. And in this case, I'm using the CloudFront secure cookie capability, as I talked about, to actually verify that I'm actually authorized to view this content. So this is my front end application that has the player embedded in it, as you'll see in a minute. In the cookies, there is no cookie generated yet. So if I go to my content here and I try to play it, click here to play, you'll see that it starts playing it. It has actually created a cookie. So let me actually go right here. As you can see, there is the signed cookie that is generated by the application, the front end application. And CloudFront is verifying that every single segment that is returned, that the cookie is actually placed there before it actually returns that segment. And if we look at the network piece here, as you can see, these 10-second segments are being requested by the player through CloudFront. And for every single segment, there is the key that it requests. That key, by the way, is the key which is an encrypted key and is decrypted by key management service. So that is a quick demo for a VOD secure delivery with HLS with AES encryption. What I will do now is I will forward it to Ryan, who'll take it from here and talk about live streaming using Wowza.
Thank you very much, Usman. Hi, everyone, and thanks so much for having us for the webinar today. And hopefully you guys can all see my screen okay. But we're very proud that Amazon Web Services is a Works with Wowza partner. We work very closely with AWS, and a lot of our customers leverage the Amazon Web Services platform, both for the cloud computing with EC2, as well as with Amazon S3 for simple storage for VOD delivery, and then of course CloudFront for CDN delivery. So those are kind of some of the components that Usman has touched on, and I'm going to be speaking more specifically about the live workflow with Wowza and with AWS. So real quick, I'm just going to, for those of you who maybe aren't familiar with Wowza, I was going to talk through a couple of slides, but one of the things you guys may be familiar with AWS Marketplace. If you just go to AWS, you can just type in Wowza and search for that, and you'll be able to see right in here that you can actually spin up an instance in literally just a matter of minutes. So you can see here, this is a standard pricing model where both the Wowza software usage as well as the AWS cloud computing usage for EC2 all gets billed directly through your Amazon account. So if I select that standard model, right in here you can see here it's a breakdown of all the fees for being able to use Wowza with the EC2 usage. You can do that with a selected, the selected regions. I know the Frankfurt region was actually just added recently, so that's great that we have more coverage for Europe as well. And the whole idea here is this would actually be the origin server where you ingest this live stream. So if you actually, let's say you are based in Germany, you would want to select a origin region that's very close to you. And in here you have some additional details about this particular Wowza streaming engine. So if I go ahead and select one, I'm actually based on the west coast of the United States in Oregon, so I'm just going to go ahead and select that, and I'm going to click on continue. Right in here, you can configure this to actually do a one-click launch. So very simply, you can actually pre-configure this with the most recent version, which we just updated our armies with 4.1.2. So I can very easily select that or a previous version of Wowza streaming engine. And what this will do, it will pre-build this virtual machine based on the settings that I have configured here. One of the great things here is we often get the question as to what EC2 instance someone should choose. And of course, it's hard to answer that question because a lot of it depends on how large your audience is going to be, how much transcoding are you going to do, how many concurrent live streams are you doing on this one cloud computing machine. All those are variables that you need to take into account when selecting a particular instance type. It's very easy just to say, hey, select a very large C3 8x large, but of course that's going to cost quite a bit extra to actually spin that up in the cloud. So you want to be able to balance this and test this with your particular use case. One thing that we do have is we have a Wowza Transcoder performance benchmark report that we put out on our website. And one of the great things about this report is we actually did this just at the end of last year. We used several different EC2 instance sizes to do these benchmarks. So if you come right down here to server 7 and server 8 inside of this report on our forums, is right in here we can actually tell you the performance based on these two specific server instance types. You can see here some of the input test streams that we did for different inputs, so 1080p or 720p, and you can see here the matrix of the performance for those particular instance sizes. So it's a very good indication, to maybe get some kind of an idea of what kind of an instance size you would need for your particular live streaming needs. So if I come back into AWS Marketplace, let's say I do want to select an M3X large, I highly recommend you do an EBS-backed machine. That allows you to very quickly stop and start those instances at a moment's notice. And then one of the things that we've been focusing on is security groups. We've worked with AWS very closely to make sure that these security groups are configured with all the right ports to be able to stream in and stream out, so ingest and output a stream from that EC2 instance. So all of those are actually specified here. And if you are concerned with restricting the incoming IP addresses of your encoder or being able to output to a specific range, a lot of those networking restrictions can be done on the AWS platform right inside of the security group. So that's a nice additional pair. And then from an access perspective, you can actually create a key pair to be able to make sure that only certain people can access that EC2 instance. And really, as soon as you click launch with one click, it will spin up that instance and it will be available within just a couple of minutes with a pre-built instance of Wowza Streaming Engine. So now that I've given you a quick overview of how you would spin up a Wowza machine, let me actually jump into the slides and I'll give you a quick overview of how that's working. So like I mentioned previously, Wowza Streaming Engine is a robust, customizable, and scalable server software that actually allows you to do reliable streaming of high-quality audio and video to any device anywhere. It's used both for live and for video on demand, and you can very easily use AWS Marketplace to live stream using an EC2 instance, be able to leverage Amazon S3 for recording your live streams as well as for video on demand delivery, and then you can also deliver those streams globally using the Amazon CDN CloudFront. So speaking more specifically about the different kinds of security, like Usman's mentioned, there's a lot of security settings that are available through AWS. Similarly, at the application level within Wowza, there's a lot of security settings as well. So one of the things that you're able to do is actually restrict the RTMP and RTSP ingest from your encoder, but we're talking more specifically today about the output side, is what can we do to securely make sure that our stream can be DRM protected, can be encrypted from a delivery perspective. And from that perspective, Wowza can offer you quite a few options. Talking about conventional streaming protocols, you can actually do RTMP-S and RTMP-E encryption for RTMP playback. And that makes sure that you can actually do SSL or secure socket layer protection for those network connections. And this is also true of being able to communicate between different origin and edge servers. So you can very simply communicate securely between your multiple servers if you're scaling your solution as well. I think the focus of today's presentation is much more focused on HTTP live streaming. So that's really what I'm going to speak to a little bit more. We have several features, including the AES 128 encryption for Apple HLS. We also have features such as Streamlock or something like Secure Token. With Secure Token, you can actually do token authentication between the server and the player to make sure that the player only exists on, on a website that's actually certified to actually play back that stream. And the other things that we can do at the application level is do geographic IP blockings, and AWS can actually take care of doing that from the network's perspective. From the application layer, we can take care of doing that inside of our Wowza streaming engine as well. We can also do server-side API controls for IP white and blacklists. So if there's certain IP ranges that you want to deliver to, let's say in a virtual private cloud or something like that, you can very easily restrict it. We often get a lot of our customers who, let's say they have the World Cup rights for Brazil last year, they're only allowed to actually stream within Brazil. There are ways that we can do that at the application layer to restrict that as well. So in addition to the encryption side of it and all those security settings, we also can do on-the-fly DRM for any screen. So in this example, we can actually ingest these unencrypted sources. This could be from a video on demand source like Amazon S3. It could be from your live encoder or camera. So an example of encoder would be something like a Teradek Cube or a NewTek TriCaster, or even a software encoder like Telestream Wirecast. We could ingest that unencrypted stream, and then Wowza would take care of adding the encryption, but also having that DRM link to any one of these DRM service providers like ByDRM, Verimatrix, EasyDRM. And then we also integrate with DRM technologies like Google Widevine and Microsoft PlayReady, so we can have that integration on the player side as well. So not only do we get the encryption, we also get the DRM layer of protection to your content. Now in today's example, I'm actually going to be showing the Google Widevine implementation with common encryption. And this is becoming very popular because it's actually common with the MPEG- protocol to actually add that level of encryption inside of, let's say, an HTML5 player in Google Chrome. And that's exactly what I'm going to be showing in today's workflow. And the great thing about CloudFront is that CloudFront's built this amazing HTTP CDN network that allows you to leverage a lot of these features of protecting not just the encryption side, but the DRM side over these HTTP live streaming protocols. So what we can do in this example is actually take a camera source from our encoder, be able to deliver that over RTSP or RTMP into our origin server. And let's say in today's example, I'm actually doing this in the Oregon region. I could then ingest this one high quality live stream and then transcode it in the cloud, transrate it, transize it, be able to add the encryption in the DRM component, and then deliver that through CDN and through Amazon CloudFront for, let's say, MPEG- or Apple HLS or Microsoft Smooth Streaming for delivery all over the world. So the problem with doing that over a conventional streaming protocol like RTMP is the fact that you don't get quite the large scale of network that you do with HTTP, plus you're restricted on the client side as well, that with RTMP you have to deliver to a flash player, and slowly but surely you're seeing that kind of technology die off. So we really want to cater to the people that can do HTTP live streaming. So in this example, we actually have the ability to do a live stream failover as well. And Usman, maybe you can talk a little bit about how we can actually use the Amazon Route 53 for some DNS failover between different Amazon instances of Wowza Streaming Engine.
So basically, Route 53, Amazon Route 53 is our DNS service, and some of the capabilities that it provides you is first of all health checks, and you can also specify failovers DNS in the case of your DNS resolution. So as you can see in the architectural diagram at the moment, there is two Wowza streaming servers running on two separate EC2 instances in two different availability zones or data centers. So one is our active Wowza streaming server, and the other one is our failover Wowza streaming server. So Route 53 is configured such that it's pointing to the active Wowza server, and as a failover has it configured to the standby streaming server. So in the case that there is some issue with, say, your active Wowza instance, Route 53 will automatically publish or push the stream over to the failover instance, and same goes for the configuration from Wowza streaming engine directly into CloudFront. So Route 53 gives you the capability to build a highly available type of a setup within AWS.
Thanks, Usman. And I think one of the things I want to show is, like Usman said, enough with slides. Let's actually show the product in action, and I'm a big proponent of that. So I actually want to show you the demo that I have today for this. And what we're going to be doing is actually ingesting a live stream into our Amazon EC2 instance, and then being able to add common encryption and Google Widevine DRM protection for delivery through an HTML5 player. So what I've done is I've spun up this instance of Wowza Streaming Engine on Amazon EC2, and here you can see that domain name that's on EC2. And I've logged into the Wowza Streaming Engine Manager, which is our browser-based user interface to administer a lot of the features of our server software. So what I'm going to do is actually come into my incoming streams. And I've actually set up, and I'm going to go ahead and log back in. And what I've done is I've actually set up a stream here, this my stream dash. And I'm going to go ahead and pull that up. And you can see this is coming in at about 3.5 megabits per second. And what you could see when I actually logged into this is that this particular live application is set up for all of these different playback types. And you can see we have here several HTTP live streaming playback types as well, including MPEG-. So if I come into my incoming streams, I can actually pull up this particular stream and very quickly test the performance of this inside of the test player. So I'm going to click on test players. And inside of this utility, inside of the Wowza Streaming Engine Manager, I can very quickly be able to preview this over these different protocols. So if I click on Start, I can now see a quick preview of this live stream. It's coming directly from my encoder. And there you can see that live stream coming through. I could very quickly switch to these other protocols and then be able to preview that on those devices. So if I wanted to preview this on my Apple HLS device, I could copy this and be able to view that in iOS. What I want to do today, though, is actually focus on MPEG-. So I'm going to pull up this MPEG- player, and right here is a very easy copy and paste of this URL that's getting generated for this incoming live stream. So what's happening is this is coming in over RTMP, and I'm then able to transmux this on the server on the Wowza Streaming Engine instance to MPEG-. Now we could also add features like transcoding, so we could actually do adaptive bitrate. So we could ingest, let's say, a 1080p stream, create a 720p, 480p, 360p, and so on, and then be able to deliver that playlist file, through this protocol as well. But for today's demo, I'm just showing one high-quality ingest. So I'm going to go ahead and copy this. And to be able to preview this, I've pulled up the bit-MPEG player, MPEG- player. And this is actually a very good player that can be done inside of Chrome. So what I want to do here is actually just paste this URL that I've pulled out of Wowza's streaming engine, and this is getting transmuxed and getting streamed, live streamed directly from my Wowza streaming engine instance on EC2. And here you can see that EC2 domain. So I'm going to go ahead and reload this player with that particular URL. And if I scroll down here, I can see the playback that's now happening directly from EC2. So this is actually getting now live streamed, and you can see there it says live. And what's happening is this is actually being encrypted using common encryption, and then it's being delivered over the MPEG- protocol with the Google Widevine DRM protection as well. And what I've done to do this, I've actually followed this article that we have on our Wowza support forum to do this, is how to secure MPEG- streaming using common encryption. And this is actually available both for Microsoft Play Ready and for Google Widevine DRM systems. Now one additional implementation I want to show is here you can see that live stream playing back, but I want to show how you can then not only deliver this directly from your EC2 instance, I also want to deliver this using a CDN such as Amazon CloudFront. So what I've done is I've created a CloudFront distribution, and I'm actually going to use that CloudFront distribution and map that to this EC2 instance. So I've already done that on the back end. I'm going to go ahead and paste the URL of this new CloudFront distribution. You can see there is the reference to CloudFront. And what's happening is from the player side, this is actually hitting the CloudFront CDN, hitting the actual edge of that CDN, whatever edge is closest to my playback location, and taking advantage of all the scaling necessary so I can scale this to a global audience. So it's really a great way to take advantage of MPEG- delivery using common encryption, using Google Widevine DRM, but then also leveraging the power of the CloudFront CDN as well. So I'm going to go ahead and reload this, and it's a little transparent. You don't really see much difference on the playback side. You just have the knowledge that this is actually getting done using this because I've set this up on the server already. Now, one thing I want to show is while this is loading is if I come in here and look at my developer tools, just like Usman showed earlier, is I can actually show what's going on here on the network side. So if I come in here to the network, you can see here are those chunks that are getting loaded, and then I'm actually also able to see the keys that are getting generated. So you can see every time a chunk's getting generated, you can see here is that license that's getting loaded directly inside of the player. So the player is actually requesting this and actually getting that, adding that layer of common encryption plus the Google Widevine DRM protection as well. So all this is happening with that integration with CloudFront and from Wowza Streaming Engine as well for live streaming. Now, I want to point out that this workflow that I'm showing is useful. It can be used not just for live streaming, but also for video on demand streaming from Wowza Streaming Engine as well. And you can see here all those chunks getting um, requested from the player. So that's pretty much just a quick overview of the live streaming demo. Usman, do you want me to turn it back over to you? And I think that's it from the Wowza side.
Thanks, Ryan. So I will be a quick recap right here. Share my screen. So quickly recapping, this is our sample AWS architecture for VOD and live streaming, and I covered that, and thanks to Ryan, he covered the live streaming piece. So as I talked about from a media owner perspective, whether that be an RTMP stream or a file that's going into an S3 bucket, so whether a live or a file-based workflow, you can really automate it and use Amazon Key Management Service, some of the feature set that is built into the platform to really secure your streams. So first of all, you as a content owner will create a primary key on Key Management Service, and then use Key Management Service to actually vend or issue the envelope keys or the encryption keys to services like Amazon S3 Bucket or Elastic Transcoder, or even an EC2 instance that is running Wowza. So you can certainly integrate with a DRM service, as Ryan talked about, or if you want to do simple encryption, key-based encryption, you can manage all that throughout the native feature set that is built into AWS. And S3 will also integrate nicely with the key management service to encrypt your files or the content while it's at rest on S3. And then finally, we talked about CloudFront security features or CloudFront private content feature. So in this particular demo, we used the CloudFront secure cookie capability to allow or deny customers to access a manifest file. And then based on that, the content is controlled as to who has access to it. So thank you very much